I feel I must take the time to put this message at the beginning of the video that the advice that I'm providing in this tutorial is simply as is, and there is no sort of warranty or protection for your injuries that you may cause yourself. So if you attempt it, I just want to remind you that's your own doing, and be careful when you're doing so, because voltages and sharp glass are theoretically present when working on Christmas light strands. And also, do make sure to wash your hands when you're done handling Christmas lights, because among probably other chemicals, I know that for somehow they manage to use lead when they make these things. But with that being said, with incandescent Christmas lights, as cheap as they are, you might be wondering why you would bother repairing them. And for me, the philosophy is very strong that if something can be fixed, it's better to do so than to buy another one. And frankly, I think that's one of the largest issues that society faces, is that of how how acceptable it is to simply throw out an old item rather than fixing it, and companies actively making it hard to fix things, and parts not being available is another thing, and non-standard stuff. But thankfully these are fairly easy to actually repair most of the time. It basically only just requires a bit of time. So with that being said, if you are interested in repairing some of your Christmas lights with issues, this video is for you. Now let's get on to the main part. Alright, hello. So starting this mini how-to series, or at least that's how it's going to look like coming out. This is going to be how to repair Christmas lights. We're going to be looking specifically at the incandescent Christmas lights, because that's what my mom always buys. Even though I strongly favor LEDs, and in fact it is what I have out here. But those are all season lights, or so I call them. But anyway, we'll start by looking at a perfectly functional strand, just as a baseline. Because with the reliability of these light strands, you may want to actually see what a fully working one looks like. This one is relatively new. I think all the bulbs in it are actually lit. So if a bulb was to burn out, if everything is working correctly, what's going to happen is the strand's still going to stay lit. And I can't exactly explain the process because I don't know it, but there's a little shunt in here that like activates when the bulb burns out, and that passes the current. And you don't want to let bulbs burn out, because the higher voltage creates more heat, and I believe it would shorten the life exponentially, or whatever the inverse of exponential is. Well, I guess exponential is the right word, but basically each bulb that goes out puts more strain on the rest of them, because higher voltage, because a shunt by definition has very low resistance. If the shunt fails, which it shouldn't by design, you'll notice that half the strand, or if you're working with usually smaller strands where the entire strand is on one circuit, that might make the whole thing go out. And if none of the shunts fail in the process, which seems to be rather unlikely from how I've seen it, I've only ever seen one that came close to burning out all the bulbs, but like the last half of the bulbs will go really fast. There was one bulb left on that strand, and its shunt burnt out, and as such it didn't blow the fuses, because that's what's going to happen if all the bulbs become shunted. That's just going to be a short, and your fuses are going to blow. So to get started repairing, if your entire strand is not light, and usually if whatever is connected to your strand also does not light, I would check the fuses. You just get either a fingernail or a screwdriver, pop this open, and there's fuses in there. You usually get either 1 or 2 pairs of replacements in every bag of, or every box of Christmas lights. But it's a 3 amp fuse, which I would say that that's kind of optimistic for what you should be attaching to these. But anyway, this is a perfectly functioning strand, and none of mine, to my knowledge, have burnt out fuses. That is one thing. Never ever discard the freebies that you get with your light strands. I have a container that I put all of the lights that I unpackage. I put the extra bits in here, and some random junk is made in here too. But you can see I've got like bulbs and the flashers, which are incredibly annoying because you get like 18 million of them because nobody ever uses them. And somewhere down in there I do have fuses, but I'm not digging for those because I don't need one. But anyway, one thing you might want to consider is you might want to find a strand where you have like a lot of lights burnt out, and that can just be your salvage strand that you're just going to pull parts from. Especially if you're doing a lot of strand fixing, which if you're a half serious decorator, you probably have enough lights that's how it is. I do have a salvage strand poking around here, so just give me a moment and I'll try to find that. Okay, so this is my salvage strand. You can see that I've already started pulling bulbs from it. A good salvage strand would be one where the cord is damaged in a not easily repairable way, or if you just simply cannot figure out what the issue is, or simply just the one with the most bulbs burnt out. As you can see, I've still got half of this that's actually working, and in fact it's working quite well. But I don't think I was ever able to diagnose this one, and it's not going to work now. As you can see, I've been pulling bulbs from it and then putting the sockets back in, because that is a lovely thing. Everybody uses their own slight variation on the socket. So let's get these out of the way. Okay, so we'll set that one aside. I guess we'll start with this one. I have no idea what exactly the issue is with all of these. I just know that they all have an issue. First thing I'm noticing is you can see how very, very few lights are actually lit up. And I'm seeing a lot of burnt out bulbs. So I think this one might just have an issue of a failed shunt. I'm going to come back to this one actually. I want to start with something that is not going to take an incredible amount of time replacing bulbs. That is another thing. If you replace bulbs, you want to make sure that they're rated for the same or higher voltage than what you're putting in. So you might want to try to get a really short strand to be your salvage strand, or if you're buying bulbs themselves, make sure that they are rated for a high voltage, because the highest voltage bulbs are just going to be dim, and the lowest voltage bulbs are just going to probably go boom, and that's it. Okay, so this one, you can see we do have some burnt out bulbs here on this first part. There's not terribly many, but I'll definitely replace those by the time I'm done here. And this strand does appear to be relatively new as well. I'm not sure if it shows up on the camera well. The painting on the glass is still relatively vibrant. They make very rich colors as opposed to like a sun-bleached color that old strands typically are found having, as long as they're either stored in sunlight or used a lot. Okay, so the first thing you want to do is you want to look at the bulbs and see what exactly you're dealing with. And unfortunately, I do think that this is going to be one of those ones where simply a lot of bulbs have burnt out for whatever reason, and a shunt has failed somewhere. Because if you look at the bulbs closely, it's a lot easier with clear bulbs, but you can still kind of see that they have like a dark ring around them usually. So let me get a bulb testing device. So you can see here, I've got my Hold Peak HP90K data logging capable multimeter. Literally any multimeter I've ever seen will do. You just need the resistance testing range. I don't know, I guess that's not terribly invisible. If you have an audio testing range, that's going to be the best one to choose, and that makes a noise when there's continuity. The noise may vary depending on the level of continuity, and at high resistances it generally won't make a sound. So it's easiest to just start on one end of the thing and work your way down. Pull out the bulbs. I would recommend doing this on a not live set of lights, as theoretically this is AC voltage, though in series the voltage is fairly low, but trust me, you will feel it if you do manage to give yourself a shock. So this is a bad bulb, but the shunt is good, and it's actually kind of hard for me to talk and put the leads on here at the same time, but yep, that bulb is good in pure electrical conductivity-ness, but I'm not going to put it back in because it's burnt out. I'm just trying to find the one with the failed shunt, and presuming you can tell that all of your presuming you can tell that you don't have nearly all of your bulbs burnt out, just look for the one with the failed shunt and replace that, and you should be good to go. But if you have a lot of burnt out bulbs, because you're going to just burn out more, or theoretically create a short and also kill your fuses, you wanna rule that out first. So I'll move on to the next one here. And that one's also good, but I think failed. Yeah. Okay, so I'm not going to bore you with this probably 10 or 15 minute process of checking all. Well, actually, this is a rather short strand. It's not going to take that long. But in any case, with the magic of video editing, we will be back as soon as I find the bulb with the failed shunt. Well, that sure didn't take long. It was literally the next bulb I did. So it doesn't matter since I'm already going to need to replace all these bulbs, but anyway, that's what I'll do now. When all your bulbs are burnt out, you might as well just, if you're going for saving the strand, you might as well just pull them all and assume that they're all dead, because it's highly unlikely that if you can see that almost all of them are burnt out, that any are still going to be good. So you can see now I have removed all of the bulbs from this side of the strand, and then I'm going to start pulling them from the donor strand. You never want to get rid of these bases, because it's definitely not a given that that the strand you're pulling from is going to have the same or even a base that happens to fit into here, let alone well. So now I'm just going to pull those off and do this. So to my disappointment, the bases on this, although they might have the appearance of being bigger because of the ridges from the donor strand, the bases fit, but they're far too small to hold themselves in. So what you're going to do to get the bulb out of the base, I wouldn't recommend just pulling it, because you're likely to rip the little filament wire here, even though I'm calling this filament wire, but it's definitely not filament wire. But it's that kind of fragility, if fragility is even a word. And then you just pull them out, and you take your base, and you want to make sure that your wires are not crossed, otherwise your bulb is not going to light up. And it does take a little bit of finesse to get the little wires to go in there, but I assure you it is definitely possible. And there we go. Just push the bulb in, it should fit snugly, and then you just wrap your little wires around the sides. Doesn't need to be too precise. And then you can just plug it into the socket. If you're replacing individual bulbs, of course, you might want to try to pick out a bulb on your donor strand that is the same color. But it's relatively straightforward, just a long, repetitive process. So as you can see, I've definitely pulled a lot of bulbs off of this one. I guess we're ready to test this. You can see my pile of discarded bulbs. Yeah, I think you can tell that these are a slightly different type of, or not type, but manufacture of bulb, I suppose, because they might be a little bit brighter, and also I think their colors are slightly weaker. But that could just be age, but I think you get what I mean. We've got one bulb that apparently must have been burnt out on the previous strand, or it's not connected properly or something. And then I've got a couple of bulbs, which you can't really see due to the camera angle, I suppose. I got a couple of bulbs on this side of the strand that I'll fix. So there we have it. That one strand is all repaired. Every bulb on it is now lit. I am using one Halloween-ish bulb, just because, I don't know, for some reason that was stuck into my donor strand. But it's certainly a nice serviceable strand now, and it should be good to go for a while. Alright, let me clear this here. There we go. So the next thing you'll run into, this strand is a one where you plug it in and it does nothing. So, well, okay, it does something after a slight delay. Okay, so I guess that gets into my point of, I guess it was just from this swinging that it turned back on, but you want to, what you'll find that'll fix stuff like that is, if this is your problem, you just want to shake the bulbs, just go, and this is what I'd start with if you have a mystery strand that you don't know why half or all of it isn't working. This one must just be one circuit, which it's older, so that's to be expected. But basically, how you'd fix that is you just go and push every bulb in, and if you get through that and you're still not having it, maybe reseat the bulbs, unless you have a suspicion that maybe you have burnt out bulbs or whatever. I'm going to double check here, but I think every bulb in this strand is still lit. Yeah, okay, so this strand is good. There wasn't really too much wrong with it. But another thing that you should check right away, especially if you have a newer strand and all of it is not lit, and especially if you're not getting anything out of here, is if the fuses are good, which we've went over that. A burnt out fuse won't have any conductivity, or maybe very, very low conductivity, as in a high resistance. So you can check fuses either with a dedicated fuse tester, which uses a 9-volt battery to pass voltage through the fuse and either light up a light or move a meter or something. Or you can just measure it using the leads on the multimeter in a resistance mode, which is how I would be doing it out here. And you can see this one doesn't have the winding in it all that great anymore. I'm not exactly sure how to do that in such a way that it would stay. Alright, so here we are on the next strand, which does look a lot like the previous strand. And you can see it's doing the same thing, actually. So just the shake test, drop it but not too hard test, same thing. So before the batteries decided to die on me, we were talking about this other light strand, and I guess we're going to go ahead and see what the state of the fuses is. I did actually get out my battery fuse whatever tester, just because that would be slightly easier. And if you can see that on the screen, it's saying that that fuse is good. So we'll look at the other one. I don't really suspect that the fuses are bad in this, but you might as well start with what's simplest. And then, let's see, this one. Yep. So 2 good fuses, which means, somewhat unfortunately, that our problem is more complicated. So similarly, presuming that these actually fit across here, I could use this to test the bulbs. I might need to do that. Well, the best I could do, which is not very convenient, is unbend the leads and test the bulbs that way. But since that's a lot of effort, I'm just going to use my multimeter. And we'll come back when this is done. So a few bulbs in, I did find the culprit, presuming we're lucky enough to have just one. So we just need to swap out this bulb for a working one, and we'll be back on the road. Alright, so I actually did have a bulb replacement in my tin can. And, well, you know what that means. That means that there's another one, which is actually kind of strange to have a double failure. Unless something else is just loose. But I guess we'll have to find out. So, there was actually 3 bulbs on this that were, I guess, both burnt out and not shunted correctly. Which, the only way I can surmise that happens is, I guess, just sitting around. Maybe these sat around for several years without being used, and the hot and cold cycle of our relatively unheated storage room just got to it. I couldn't find any more. White lights or clear lights after replacing 2 of them. So this has an orange light for now, which it's honestly not too terribly off. It's just, more hardcore yellow. And then there's one more that's still burnt out, but I'll definitely find some correct bulbs for this. But anyway, I do have more strands to fix, but I think I've covered everything, so that is pretty much an overview of basic things to do to repair Christmas lights. Some considerations that must be brought up is they do have a what do you call it? I guess just like a little tool that you use that, I don't know, but somehow it pulls the old bulb out and pushes a new one in. So for replacing just simply burnt out bulbs, that would be a wonderful tool. But yes, thank you for watching. If you have any questions or comments, feel free to leave them in the comments section. And I hope you found this video helpful, and stay safe when you're doing this kind of stuff, because you got glass and electricity. So yes, be careful.